Do you want to learn, understand, and master advanced chemistry? That might be one of the questions which you've been asking yourself. How are you, everybody who is watching this program? My name is Olenjolain, Mokota Yellow Single. Simply just you can call me Olenjolai. I thank God by His own grace, I'm a Tanzanian, and this is our national flag. I would like to take this opportunity to welcome all the national and international students into our fantastic program. We are here in order to teach, train, incubate, mentor, and even guide some students who will be serious and would like to master and see how they can solve real-life problems by using the knowledge that we are teaching them in the classroom, and also by using some other knowledge that we'll be incubating to our students. So regardless of your previous take right now complaining about the advanced chemistry, I want to tell you that you should not give up. I know you have been trying different ways to fix up your challenges on mastering and understanding advanced chemistry, but possibly they didn't work. I want to ask you that before you give up, please try to visit our Tanzania online advanced secondary school in square bracket Olenjolaim. So we have a good news for you today. We ask you to tune and also to join us because we would like to take you from one step to another step. Just to briefly introduce to you, I would like to take this opportunity to welcome all the national and international advanced secondary students into one of our online schools that called TANZANIA Online Advanced Secondary School in square bracket Olenjolaim. Simultaneously, because I'm also teaching mathematics, so we used to have simultaneous equations, I would like to welcome you into one of our official YouTube channel that called TANZANIA Online A-Level Secondary School in square bracket Olenjolaim. So we are very serious in this business and we have a great vision to make sure that we train our advanced secondary students by using the syllabus and curriculum of United Republic of Tanzania. However, that everything that we are going to teach you is cross-cutting. This is actually this chemistry syllabus for advanced secondary education from 5 through from 6. Advanced chemistry, it's common worldwide. Everything that we are teaching. First of all, we at Tanzania, we have never discovered anything in chemistry, so we have accepted this, or we have received the knowledge that I'm going to teach you. So if you're international students, don't be disappointed because of the country I come from or the name of the school. That should not be a great challenge to your side. However, that I would like to dedicate these contents to all advanced secondary students. All right. So I would like to take this opportunity also to welcome you. We have more than 5 departments, and one of the departments is called Advanced Chemistry, and the subject of the day is called Advanced Chemistry. So the main topic that we'll be focusing is called Organic Chemistry, and these contents are for the pre-Form 6C or Form 6C or QT or Grade 12 or reciters and teachers. So when you say teachers, so it means that the rest of them are students. Organic chemistry, we call it the main topic in chemistry because we have more than 7 main topics in chemistry, and one of them is organic chemistry. So when saying it's a main topic means that it contains some other topics, and one of the topics is called saturated and unsaturated hydrocarbons, which we are going to cover with you today. It's a kind of continuation because session 1, the first sessions was session 9, and session 9 and session 10. So this is what is saturated and unsaturated hydrocarbons. Okay, my dear students, I welcome you to join me in session 11, which is called the laboratory preparations of Alkane. So you say Alkane, it means that from methane to the higher series of Alkanes. So, in order for you to understand this stuff, you have to make sure that you go through these contents step to step. In case, another thing that I would like to invite you to interact with me through questions, also asking questions or give me feedback, for example, testimony. You may use the comment sections below on your left-hand side in order to submit your homework or to ask questions in case that you find you didn't understand any point. All right? So it's a time right now. I would like to ask you to take your exercise book, to take your pen, and then have a fresh mindset. Then be ready to receive what I've prepared for you. Okay? So, the subtitle of today's session, which is session 11, is called Laboratory Preparations of Alkanes. So let us go directly into the business. So we can prepare alkane in laboratory, so laboratory preparation. When you say laboratory preparation, there might be the national laboratory or the industrial laboratory preparation of what? Of alkane. Okay? So, just to remind you, before we teach you about laboratory preparations of alkane, alkane is it's saturated hydrocarbons. And we taught you in the previous session what the meaning of alkane, but I would like just to do the quick review. Because we need these few concepts soon. Okay? So simply say that we taught you that alkane is unsaturated hydrocarbons consist of hydrogens and carbons atoms arranged in three structure in which all the carbon-carbon bonds and carbon-hydrogen bonds are single bond. So quick review of session 9 to session 10. Okay. So simply say that in alkane, so this is saturated hydrocarbon. You can take this as the summary, hydrocarbons. Okay, saturated hydrocarbon. Okay, which contains what? Which contains all carbon to carbon and all the carbon to carbon single bond, which is sigma bond, and also carbon to hydrogen single bond. So that this is what you have to bear in your mind. And I would like to tell you that this is the beginning of the journey of how you can do conversion, how we do prepare a certain organic compound from another organic compound. Another piece of information which is very important, the general molecular, I insist you to write down this stuff, very important. General molecular chemical formula of what? Of alkane is carbon N, then so I say that it is carbon N, hydrogen subscript of 2N plus 2. Very important. Okay, so this is general molecular chemical formula of alkane. So these are the two pieces of information. So we say that alkane or alkanes can be prepared in laboratory by using different methods. Okay? There is different methods. Okay, so another piece of information, we say that we can categorize these chemical reactions of alkane. So we say the laboratory preparation or the methods of your students. You're not writing, don't know what you're thinking about. These methods of what? Of preparing alkanes can be categorized into three main groups. So this method can be categorized into three main groups. The first group, we say that these are methods so you can call them reactions, chemical reaction, chemical reaction that do not accompany change in number of carbon. So this is the first category. We say that one category of the method that we use in lab to prepare alkanes is the group of method whereby the chemical reactions that take place does not accompany the change in number of carbon atoms in that compound. Okay? So you say that carbon atom of number of carbon atoms in the compound. So you say that all of these methods takes place without increasing or reducing the number of carbon atoms. Okay? So this method, they do take place, means they do prepare alkane, means we use these methods in laboratory to prepare alkane, but there is no increase or reduction of the number of carbon atoms in the compound. In the compound or molecule. Compound or molecule. Some of the reference book we do use molecule. Okay, the first method right now, which is 1.1, is we call it hydrogenation of unsaturated hydrocarbons. Let me just call it number 1 for this case. Hydrogenation, say with me, hydrogenation. Hydrogenation of unsaturated hydrocarbons. We have saturated and also we have what? These methods are very important for the rest of your life. The method I'm teaching you right now, we are going to use it in different cases of aliphatic hydrocarbons, and also we are going to use it in different cases of aromatic hydrocarbons. So you have to remember this method because you will need it in preparations or even you learn it in chemical reactions of unsaturated hydrocarbons. So unsaturated hydrocarbons, so we defined in the previous session what does it mean about unsaturated hydrocarbons, and we gave you 2 groups of organic compounds which are alkane and the alkynes. So the first fundamental question, I know it's the first time for you to hear the word hydrogenation. So the first fundamental question that the student has to ask himself or herself, what is hydrogenation? because you can know how to do mechanism of hydrogenation, but you don't know what does it mean. What is hydrogenation? That's the fundamental question. What is hydrogenation in organic chemistry? So the answer is in organic chemistry, not inorganic. So when I say in, this is not the same way. In organic chemistry, hydrogenation is the common term. Hydrogenation. Hydrogenation is the process. So hydrogenation is a process of what? Of adding hydrogen atom. Is the process of adding hydrogen atom. The process of adding hydrogen atom. Process of adding hydrogen atom to the unsaturated molecule. Is the process of adding hydrogen atom to the unsaturated. You say it's unsaturated, it means alkane and alkyne. Unsaturated compounds or hydrocarbons, unsaturated molecule. Why are we adding hydrogen atom? The aim to add hydrogen atom is in order to form what? To form saturated compound or molecule. That's the aim. So it means that the unsaturated molecule will be the reactant of the chemical reaction, while saturated molecule will be the product of the chemical reaction. So, if that the case, that the meanings of what of hydrogenation, okay? So he said that hydrogenation. So he said the necessary condition or the catalyst required to speed up this reaction, catalyst, because these reactions may be what? Platinum, maybe nickel, may use nickel, may use palladium, etc. That is the necessary or the required catalyst, or the catalyst required to speed up hydrogenation reaction. Is what is nickel. We use nickel atom or palladium atom, or what is platinum. But again, in preparations or in organic chemical reaction, you have to think about the condition sometimes. Okay? The necessary condition. The necessary condition for hydrogenation of unsaturated hydrocarbons, saturated hydrocarbon, is temperature should be 150 degrees centigrade. Okay. So for that case now, generally, if that the case, we say that here in reactant side we have saturated hydrocarbons. hydrocarbons. Okay, hydrocarbons. Then we add with hydrogen molecule. Then we need the condition. Condition we say you may use platinum or you may use nickel. Okay, use nickel. And then the condition is at temperature, or the reaction should be kept at the temperature of 150 degrees centigrade. Then the product is saturated. I see some students who are doing something else. Those students, you have to be serious. The saturated hydrocarbons, that's the end product that we expect. Okay? And the end product that we expect to have. Okay. So this is a general weighty chemical equation. General weighty chemical equation. So if that's a fact or if that's a situation, then we have to think again in that context. So, if on reactant side we have unsaturated hydrocarbons, might be alkane or alkane, and hence it has to react with hydrogen in the presence of platinum or nickel or palladium at the temperature of 150 degrees centigrade to get the products of saturated hydrocarbons. So we say that with the general molecular formula, we say that for this case we have only two possibilities. We have carbon N, then hydrogen 2N, this means alkane, then react with hydrogen molecules under the conditions of platinum or palladium, because we have the molecular or the chemical symbol of palladium, it's Pd under temperature of 150 degrees centigrade to form what? To form saturated hydrocarbons, which is Cn hydrogen 2N plus 2. So it means that the product we expect is mainly saturated hydrocarbon. Why? Because we are adding, this is the additional reaction, we are adding hydrogen into unsaturated hydrocarbon. Then, again, we can have Cn H2n minus 2. Then we do hydrogenation. So here maybe under conditions of platinum or palladium and room temperature of 150, then we formulate to it. So here we need 2 atoms of hydrogen molecule. We get Cn hydrogen 2n plus 2. So whether we take any either we take alkane or alkyne, that would be the ending product. So if that's the case, we can have some examples. Okay. So example, we have a theme. So we have carbon and a single bond is hydrogen single bond, and then here we have a single bond plus hydrogen base. Then the condition is, let's say, platinum. Then the temperature is 150 degrees centigrade. And the end product will be this one. So you have to remember that what will be going on. The simple mechanism is we want to add hydrogen. In this double bond, we have 2 types of bonds, sigma bond and pi bond. According to what I taught you in general chemistry, especially in the chemical bonding, pi bond is a weak bond. It's the weakest bond compared to the sigma bond. So in order to add these 2 atoms of hydrogens, then the pi bond has to break down and form the free radical. So simply, if you want to understand the mechanism as a serious student, this is just the bonus for you to understand what is going on, because there's no need for you to cram too much in chemistry. So here we have a double bond. So it means that if these bonds will be breakdowns, we'll have two free radicals. And here we have 2 hydrogens, and here we have we have a hydrogen atom and hydrogen atom. So it means that this we call the homolytic privilege, right? And then also we have a hydrogen molecule, and this also it can break down to form 2 free radicals of hydrogen atom. So if that the case, 1 free radical will be reacting with this free radical carbon, and the other ones will be reacting with this one to form what? So it means under the conditions of of platinum, temperature of 150 degrees, then now we have carbon with single sigma bond. Then here we have added hydrogen. We had a previous hydrogen, and then this is a previous hydrogen, and this is a added hydrogen, and this is a hydrogen. So we have already prepared the sun. So we prepared the sun from what? From the zinc. One point you have to note, in the reactant side we have 2 number of carbons. Also on the product side we still have 2 number of carbons. That's why we say hydrogenations is one of the laboratory preparations of alkane which does not change the number of carbons. Okay? So if that's the case, then now I would like to give you a quiz. Okay? So here we have CH3, we have CH2, then we have CH, then we have this one. We do hydrogenation. Okay? Do hydrogenation. Then under the same conditions we have platinum and temperature of 150. Give me the product. Give me the product of this chemical reaction. And then remember that you should be relying always on the fact. So you have to be careful on the number of hydrogen atoms. So you can pause the video and try to think how the chemical reactions is going on there. And you can do a simple mechanism to understand how stuff used to go. Because I used to hear complaint from many students that they used to struggle too much, but they don't understand the beauty. They don't enjoy actually the beauty of organic chemistry. So the issue is not the product. The issue is I want you to practice the mechanism, and you should use the foundation concept or the fundamental concept that I taught you in chemical bonding. Because in organic we used to break bond and form bond. That's all. Okay, so thank you for trying. Now it's a time for correction. Let me do the correction because I want you to understand and go further. Okay, corrections of what? Of this is quiz 1. Okay, so this is quiz 1. So no, you should not be confused. So you can write the open structure of this organic compound. Okay, so you can say, okay, so we'll be focusing on mechanism. I want to show you how the mechanisms is used to go, and then check your yours. So you have carbon, you have 1 hydrogen here. This is open structure. I advise you to write this stuff in open structure. It can help you. So here we have triple bond. So here, whenever you find 1 carbon, so you have triple bond with this carbon, and this carbon has a single hydrogen, and then plus OT. So first of all, because you have a triple bonds, in this triple bond, I taught you in chemical bonding that whenever you find a triple bond, 2 bonds are pi bond and 1 bond is sigma bond. So if 2 bonds are pi bond, they are the weakest bonds compared to pi bond, so they can break down, right? And allow. So here it means we have a pi bond. So it means we need 2 atoms of 40 of hydrogen molecule. So it means that under the presence of platinum as a catalyst and temperature of 150 degrees centigrade, right? So how the process is going on? Wonderful. So CH3, CH2, this is triple bonds with this carbon, okay? And here we have an hydrogen atom. So remember that also the hydrogen, we have 2 bonds of 40 between hydrogen and hydrogen molecule. So the condition is still platinum. Let me impress my students to enjoy the beauty of chemistry. So what happened here? So the first pi bond will break down to form a free radical, and on this side also, because they have the same electronegativity, so that's why they can form a free radical, right? And then also here, one hydrogen molecule will form a free radical, and this one will form a free radical. So you have free radical, free radical. So in the case, so we have here CH3, we have here CH2. Right now, we are going to have double bond, but with what is a free radical. So free radical, and here we have what? 2, so total we have what? So we have what? We have 4 hydrogen free radicals. So under platinum, temperature of 150 degrees centigrade. So 2 free radicals will be combining with this free radical in carbon to form what? Butane, right? So it means that here we have what? We have CH3. This is for your advantage. When we ask about hydrogenations, there's no need for you to do all of this stuff. But I want my students to understand what they are learning or what I teaching them. So right now we have this one, but we have used the 2 free radicals of hydrogen. So it remains it's only 2 free radicals. So this is platinum under 150 degrees Celsius. Right? Okay? Wonderful. So if this is the case, okay, so then here we still have a pi bond and sigma bond. So pi bond will break down to form what? To form 2 free radicals. So this one and this one break down. So here we have 2 free radicals. So that's why that the product now, so on this side we'll have what? So the product now will be CH2, CH3, CH2. Then now we have 2 hydrogen atoms, and then here we have 3 hydrogen atoms at the product, right? Which is what? Methane. So how many number of carbons in reactant? 1, 2, 3, 4. Here 1, 2, 3, 4. No change of 40 number of carbons. So you have to understand, because later on we'll be using this concept. For example, you can convert alcohol into alkyne or into alkane, and then maybe the end product should be the alkyne. So you have to understand. That's why I'll be insisting you, my dear student, concentrate on laboratory preparation of a particular compound in organic chemistry and chemical reaction. That's separate. If you have any question about hydrogenations of unsaturated hydrocarbons, however, that we repeat it when we be teaching you about chemical reactions of alkane and chemical reactions of alkyne. We'll be repeating them, but because we have taught you, we'll just ask you to refer session 11. So just go quickly and you understand the stuff, then you move on as well as we can. So while I'm teaching you about laboratory preparations of alkyne, at the same time, I'm teaching you 2 chemical reactions. One is the chemical reactions of what? Of alkane. And the other one is the chemical reactions of what? Of alkyne. The issue in organic chemistry is things depend each other. So if you don't understand the fundamental concept, then you are lost as well. Okay? So for example, for this moment, I've taught you 3 concepts in one. Alright? Okay, good. So if that's the case, so we go into the next method. That's all about hydrogenation. So you can, okay, so I think that now, because I have to leave the homework for you. This is homework 11. So then complete this chemical reaction. Complete research with mechanism, just for understanding. Okay? For you to practice. Then, ladies and gentlemen, the secondly, chemical reactions of laboratory, the second chemical reactions of laboratory preparations of alkane with no reductions or no change in the number of carbon atoms is called the hydrolysis of pregnant reagents or organometallic compounds. And the next reaction, hydrolysis. That is me, hydrolysis. Hydro, so number 2 is what is hydrolysis of pregnant, which I will teach you also these chemical reactions when I'll be teaching about the alkyl halide, when I'll be teaching about alcohol. Or this one we call it organometallic compound. So this is the second chemical reaction which can be used to prepare alkane in laboratory without reduction or increase the number of hydrogen atoms. So, as an excellent advanced secondary student who like to enjoy the beauty of advanced chemistry, if I could be you who is receiving this content, my first question, what is meaning of hydrolysis? Possibly Greek and reagents, I don't know it because it's not yet to be taught, but I want to understand because the key there is hydrolysis, right? And I want to tell you that the term hydrolysis, the term hydrogenations, the term dehydrogenation, those are common in organic chemistry. So now the fundamental question is, what is hydrolysis? Because this terminology of hydrolysis, we are going to learn it in different concepts of organic chemistry. So in order for you to understand and love it, first of all, you have to understand what does it mean. All right? So that is the second fundamental question. What is hydrolysis? What is hydrolysis? That's the question that we have. What is hydrolysis? According to some references, we say that in organic chemistry, whenever you hear the word hydrolysis, in organic chemistry, hydrolysis is a chemical breakdown of a compound due to reaction of what? Due to reaction with the water. So the term hydrolysis is come from the term water, hydro. Water, remember the elements which form the compounds of water are hydrogen and water, hydrogen and oxygen. So in organic chemistry, hydrolysis is the chemical breakdown. So this is the chemical breakdown of what? Of a certain compound due to what? Reaction between that compound and water. So whenever you hear hydrolysis in organic chemistry, it means something reacting with water. Does it make sense? Wonderful. So we say that hydrolysis of pregnant reagent. So what does it mean? It means pregnant reagent reacts with water. That's all. Right? So when it reacts with water, what are we going to formulate? Unsaturated hydrocarbons, which is what? Alkane. Okay. So if that's the case, we say that generally, the word chemical equation, generally, we say that we have pregnant reagent, okay, plus what? So plus water. The product is what? The product is alkane. Okay, product is what? Is alkane. And then plus what? Plus metal hydroxide. Plus metal hydroxide halide. But this is the remaining part, it's an inorganic compound. It's an inorganic compound, so we are not focusing on that. Okay? So the main point is if pregnant reagent undergo hydrolysis, the product will be alkane. Product is alkane. So again, you have to remember the general chemical molecular formula, and then you have the we call it alkane. So the same reaction, we can say that in most cases, pregnant reagent is RMGX. R represents organic compound or part of organic compound. RMGX. Then plus what? Plus water. The product. Okay. Product is what? The product is alkane, which is RH, means that one addition of one hydrogen atom, plus what? Plus magnesium hydroxide X. Okay? Sure. Okay. So this is the overall reaction. So remember that for your first time, R represents what? Alkane. Simply represent what? Carbon chain. Or represent what? R represents hydrocarbon. So when you say hydrocarbon, it means represent hydrogen and carbon. Right? And the X representing halides, or in other words, halogen. Right? So you have to understand that because this is the way we used to communicate worldwide in case of organic compound. So remember, this represents hydrocarbons. What does it mean? It means R always, it's a compound made by carbon and hydrogen only. Alright? And the X represents halogen groups or group 7 element. For example, fluorine, chlorine, bromine, iodine. Right? Mg, this represents this is capital M. Should be a capital M. This represents magnesium. So example of this chemical reaction, we say that, for example, we have CH3, then magnesium, chlorine. You see? So this one, CH3 represents R, right? Then chlorine represents X. So undergo hydrolysis. The catalyst and even the conditions is not necessary to be known. The reactions can take place without even catalyst and condition. So then, remember, water contains how many lone pair? 2 lone pair. So water is reactive because remember, water itself in this state without lone pair, it's unreactive. It's a neutral molecule. Why? Because hydrogen has reached its octet state, and also oxygen has reached its octet state. But remember that oxygen still containing two hydrogen, two lone pair. I mean, these are the two, this is the pair of electrons in the valence orbital, right? So this lone pair, because remember I talked about Lewis acid, Lewis base, right? I talked about those stuff. So it means that this can make water to be reactive. Okay. So then, how the reactions is going to take place, you have to understand, listen carefully. So mechanism, this is for your advantage. In some of the cases, and most teachers, they use just to give you product. So if they give you product, you have to think the outside the box, because otherwise you'll be cramming. Okay? So the ability to do mechanisms avoid you or rescue you from cramming. Right? So you have to know how stuff used to go, because this is chemistry, it's a beautiful subject. So simply, here we have an open structure of carbon-carbon hydrogen, and here we have magnesium, and here we have chlorine. So we have water, but water itself also is bonded with hydrogen. So look the process that will be taking place. Here we have electronegativity difference between carbon and magnesium. Carbon is more electronegative, right? And this, because this is metal and this is non-metal, it's electrovalent bond, not covalent. So if you do remember what I taught you in chemical bonding, which one is strong? Covalent or electrovalent bond? Remember, electrovalent bond, it means that you concentrate, focusing on what? Donating, it means the metal donate electrons while the non-metal received electrons, right? While covalent bond, focusing on what? Sharing of what? Of electrons. Are we together? So for this case, this is covalent, electrovalent bond, and this is electrovalent bond. But our focus is this organic compound. So the bond will undergo what? Which type of reaction? Heterolytic cleavage. So carbon becomes nucleophile, and this carbon becomes what? Electrophile. This becomes partially negative, and this becomes partially positive. Okay? So we have water. Then what happened there? We have bond between hydrogens and oxygen, and we have oxygen. So that's the only bond that we can break down. Right? But electronegativity difference between oxygen and hydrogens is not the same. Which one is more electronegative? Oxygen. So when this bond breaks down, all the bonding electrons will be drawn by what? Oxygen, and this one becomes partially positive. Right? So we have new electrophile will be reacting with nucleophile. We have nucleophile will be reacting with what? With nucleophile. We have electrophile reacting with nucleophile. Electrophile reacting with this nucleophile. Then you have the product already. No need for you to cram. Why are you cramming? And then you're expecting to be, I want to be a pharmacist, and then you are cramming. Okay, so here we have hydrogens, and then we have hydrogen, and here it means there's a new hydrogens will be added into this reaction. Then look, remember that magnesium used to donate 2 electrons, so it used 2 electrons, right? So 1 electron is already donated into chlorine. When this bond breaks down, it means that it needs another atom, whereby magnesium will be forming a bond with what? With hydroxide and also with chlorine. How this bond is formed? So if you want to understand, it means that magnesium, so you have a bond here with hydroxide, and also it is formed a bond with chlorine. Okay, are we together? So now we have what? Methane. Okay, yeah, that's how life goes. Now we have methane. So this means that the product here is methane plus what? Plus magnesium hydroxide chloride. Plus magnesium hydroxide chloride. That is. Okay? So for that case, now you can try. The good thing for this one, we don't have two options, we have only one option. So now we can have CH3, CH, and here we have magnesium chloride, then we undergo hydrolysis reaction. So the quiz, this is quiz 2, complete with mechanism. Okay, so spend at least 3 minutes to do the mechanism for that chemical reaction. Everything is simple there. Yeah, it's very simple. The third chemical reaction, which does not change the number for carbon, is called the reduction. Stay with me, reduction. Reduction of what? So remember, these chemical reactions will be used to answer questions of what? Questions of conversion. Reduction of carbonyl. Reductions of carbonyl compounds. Reductions of carbonyl compounds, and these reactions have a special name. We'll also cover it later, but if you understand, in the next step, I'll just remind you, then quickly we go as well as we can do. It's called the Clemenson's reaction. This chemical reaction is called the Clemenson's reaction. So reductions of carbonyl compounds. I know it's the first time for you to hear about carbonyl compounds. Carbonyl compounds. Say carbonyl compounds. So what the means of carbonyl compounds? So those are the compounds which have what? Yeah. So these are the compounds, it means that aldehyde and roti and ketone. Okay, so reductions of carbonyl compounds or Clemenson's reactions. So carbonyl compounds, we mean aldehyde and the ketones. We'll teach you later on. So before we teach you the reaction, let me just give you the overview of carbonyl compounds. So these are the new compounds for all advanced secondary students who are beginners in organic chemistry. So carbonyl compounds, we say that are compounds of what? So carbonyl compounds are compounds of aldehyde and the ketone and ketones. Aldehyde and ketones are the meanings of what? Of carbonyl compound. I know that possibly you have never learned these compounds during your O-level education, but we are introducing to you and we have a special topic for that. So what is reductions of carbonyl compounds? Or simply the question is, the fundamental question I'm about to end this session. So this is question 3. What is Clemenson's reaction? So simply Clemenson's reaction So we say that the process reaction is a chemical reaction. The chemical reaction which uses carbonyl compounds into alkane, when the necessary condition is presence of zinc and the concentrated hydrochloric acid. That's the meaning of what? Clemenson's reactions or reduction of carbonyl compound. So it's a chemical reaction which reduces what? Carbonyl compounds into alkane. What it means of reduces? It means carbonyl compounds has a large number of atoms compared to the alkane. So for example, if you take a carbonyl compounds which have maybe 3 atoms or 4 atoms, so because we undergo reductions, so the alkane which will be formed will have a less number of atoms. Are we together? Yes. That is the meaning, because we have to understand the language that's going on. So we say that yes, amalgamated zinc in the presence of concentrated as a catalyst. When the catalyst is not necessary condition, these are the catalyst. When the catalyst, okay, so I think that let me change the entire sentence. So we say that it is a chemical reaction which reduces carbonyl compounds into alkane, and you put comma. Under the presence of what? Of zinc and the concentrated hydrochloric acid as the catalyst of this reaction. So the catalyst for the reactions is zinc or mercury, some of the cases, and concentrated hydrochloric acid. So generally, the reactants here in this reaction will be carbonyl compound. This carbonyl compound will be treated under presence of zinc or mercury, which you call it amalgamated zinc. Okay, but also the necessary catalyst is concentrated hydrochloric acid, and the product will be alkane. Purity will be alkane. So if you want to write according to the molecular formula, we can say that hydrocarbon, this is carbonyl group. So if it's aldehyde, here we have hydrogen, under the presence of zinc or mercury. This is concentrated hydrochloric acid. Then it form what? It form alkane. So it form alkanes or carbon, then CH2. Plus zinc oxide plus zinc chloride. Plus zinc oxide plus zinc chloride. So this is alkane, right? And this is what? Aldehyde. Are we together? If the carbonyl compound is ketone, so the molecular formula will be this, and here we have R dash. So it means the number of carbons in this R, or in this part of the chain, is not the same. It might not be the same with the number of carbons in this. Please look here. This is the general formula of ketone. So when they undergo reduction under presence of zinc or mercury with concosulfuric hydrochloric acid, then now the product is R, CH2, R dash, plus what? Zinc oxide, plus what? Zinc chloride. And this zinc chloride, it will be 2 molecules because zinc ionized by losing 2 electrons. Why are we using this general molecular formula? Is in order to give you the big picture, because if you give you a single example, then you might think that reactions can take place when that single carbonyl compound is used as a reactant, right? So example, so if you have CH3 and this one, this is an aldehyde. Yeah, in the presence of zinc or mercury. Then here we have concord hydrochloric acid. Then the product is CH3. Then what? CH3. Right? Right? Plus what? Zinc oxide. Plus what? Zinc chloride. Remember, the reactions does not change alterity. The number 40, number of carbon. If, for example, we have what? We have cyclobutane, and then this one attached into this guy. Then here we have CH2, 5, and about this chemical reaction in the presence of zinc, mercury, and concentrated hydrochloric acid, right? So the product for this case, this is cyclobutane. Look, please. Look here. So this is a branch. This is branched in. It's a branch, but the functional group is what? Is aldehyde, right? So carbon, then this carbon will receive 2 hydrogen, right? And then here we have what? You can also write in this way, the open structure, and then this one. So, right, CH, and this one, then hydrogen, plus what? Zinc oxide, plus what? Zinc chloride. Okay? So how the reaction, so listen, these reactions of reduction, you cannot show its mechanism, but you can understand. Listen, these reactions have, when this reaction takes place, it's going to break sigma bond and pi bond. Listen, you're sure. When this reaction takes place, it means that this catalyst, either of these 2 catalysts, means that the 2 catalysts which will be used to speed up reaction will break the pi bond between carbon and oxygen, and also it break the sigma bond between carbon and oxygen. Right? So when it breaks, it means oxygen will need to gain 2 electrons. Right? So while zinc, when zinc ionized to form cation or zinc ion, it uses to lose what? 2 electrons. So the 2 electrons lost by zinc will be received by oxygen. That's why we have zinc oxide. Are we together? Are we together? Again, when we break the bonds, carbons will be missing how many electrons? Carbons can form 4 bonds. Here we have 1, 2, 3, 4. We broke 2. How many bonds will be remaining? 2. So it means this carbon, however that oxygen has already left it, but carbons is deficient with 2 electrons. Right? Means carbons is still rich, means that carbons is deficient because oxygen is more electronegative more than carbon. Right? So what will happen is, this hydrochloric acid should be 2 atoms. So the bond between hydrogen and chlorine will break down to form what? Hydrogen's ion and chlorine ion. So because this is a breakdown, so the carbons will become nucleophile while this one. Okay, so you should not be confused which is nucleophile and which is whatever. Right? So it means that 2 atoms of hydrochloric acid will be added into carbon. That's why here we have 3 atoms instead of 1. 3 atoms of hydrogen instead of 1 hydrogen atom. Are we together? Are we together? And then we have what? Chlorine. 2 atoms of chlorine because we took 2 atoms of hydrogen. Right? So the 2 atoms of chlorine mean that combine with zinc to form zinc chloride. That's how. Are we together? So you may not be sure how you can show the mechanism, but you have to understand how the reactions take place. Right? So the reactions actually deal with this bond, pi bond and sigma bond between carbon and oxygen. And if you're doing conversions, you'll be asked the questions of conversion, this is the essential product. So this is the only product that you require in case of organic chemistry. Are we together? So if that's the case, let me leave the homework. This is homework 7. Okay. Complete the following with aid of description on bond breaking and the formation and forming. Okay, so complete the following with aid of descriptions and the descriptions on bond breaking and formations as I've explained in the previous example. That's example 1 and example 2. So the first one, this is what? We have CH3, CH2, C, then carbon bonds with oxygens, then cyclopropane, undergo reactions in presence of zinc and concentrated hydrochloric acid. This is against undergo the same catalyst, then give us product with descriptions of 40 of bond breaking and bond formation. My dear student, this is the end of session 11, and this is the end of the first group of first category of the method of preparing of laboratory preparations of 40 of alkane, where there's no any change of number of carbon. For instance, here we have 2 carbons, the end products also have 2 carbons. So I invite you to join me in the session 12 when I will teach you about the other 2 remaining reactions. One reaction which increases the number of carbons, and the other method of preparing alkane which reduces the number of carbon. So that will be covered in session 12. You have to make sure that you don't miss it. Make sure to do this homework and submit the homework in the comment section. In case you have any questions, so you didn't understand, don't hesitate yourself, ask in the comment section in order for other students worldwide to help you and even myself. Lastly, I have just a couple of announcements. In case you feel from your heart that you want to offer our God your feeling thanksgiving for this program, then you may send your feeling thanksgiving through this telephone number 0759745331 of any amount. And your feeling thanksgiving will be used to pay the running cost because you have a vision to record more than 600 videos to teach 8 subjects of advanced level. So until we meet in the next session, this is Olenjolain from beautiful country Tanzania. I would like to ask you to keep enjoying the beauty of advanced chemistry and especially the beauty of organic chemistry. Organic chemistry is not a difficult topic the way you think, and also it's not a simple topic the way possibly you might be taking into consideration. We need the serious students. You have to be serious. Make sure that you go through these contents, you watch these videos several times, and give me the feedback whether you have understood in the comment section. So may God bless you and keep you until we meet in session 12 to enjoy the beauty of organic chemistry, especially saturated and unsaturated products. Be blessed and see you.